So let's see this problem. Insertion sort list. Problem statement given as sort a linked list using insertion sort. So okay, let's see. So we have given a linked list which are not in sorted order. Suppose we have 1, 2, 1. They should go and it 3. Okay. For insertion sort, we use 3 pointers. First pointer, which is our default head, which always points to the head of the linked list. It never moves, ever. Second is our current pointer. It moves, and our insertion pointer, it also moves. So basically we are using these 3 pointer to sort the linked list. So initially our default pointer is always pointing head, default head. Second, our current pointer which is initially at head, and our insertion pointer. So insertion pointer. Let me write insertion pointer. So let's see. We have to move our current pointer to basically we traversing the linked list through our current pointer. So how we can traverse it? While current is not equal to null. The simple way. Then we are setting our insertion pointer to default head. Basically insertion pointer is equal to default head. After that we check if insertion pointer should be not equal to our current pointer. Because how we can compare it if our current pointer and insertion pointers are on pointing on the same value? So we don't check. If we check if our current pointer and insertion pointers are pointing differently. So let's see. Suppose our current pointer moves further, else there should be an else condition, and while exiting we increment our current pointer. Current is equal to current dot next, incrementing our current pointer. So let's see. Our current pointer is pointing now towards this pointer, second node on the linked list. So our current pointer is now here. Now we will check, and there is also one condition. Let's see. There is a one condition while our insertion pointer not equal to basically not if it is equal to while, and inside while we have two condition, if and else. So firstly our current pointer is pointing the next node of the linked list. So we check, is our current pointer is not equal to current? Yes, it is not equal to current. The condition true. We come inside the loop. Then we will check what we have to check. We have to check whether insertion pointer data is greater than equal to current, is greater than current or not. If it is greater than current, then swapping of data of insertion pointer, basically swap insertion insertion pointer data with the current pointer data. Simple. If it is not greater than, we will, in else condition, we will increment it. Basically, insertion, let me write it clearly. Insertion is equal to insertion dot next. We will increment this. So this is our basically we can say pseudocode. So now we will check how it will work given English. Suppose our insertion node is currently pointing to head. Current node is also currently pointing towards head. See U double R E N T current node. So while current node is not equal to null, no, it is not null. So we can go forward inside the loop, setting insertion pointer to default head, default head. Then we check current pointer is not equal to insertion pointer is not equal to current, but it is equal to current, so it does not come inside this loop. It go outside and it will increment the current pointer to next. Then again current pointer changes to the second node of the linked list. Now current pointer is here. So now we will check our current pointer is not equal to null. Yeah, it's true, not equal to null. Insertion set to default head. While insertion pointer is not equal to current, yeah, it is also true. Then we will check insertion data is greater than current data. It is current data. Okay. Yeah, it is equal to current data. So now we will change it. Now we will change to it, it should be 1, it should be 2. Now we change. Then now we will change. Then come outside the loop. Then our current pointer increase. It should be, let me recheck. Yeah, it will come outside the loop. Then basically if then again it traverse. Now it check whether the insertion data is equal to is greater than equal to current data. No, our basically. So now the insertion pointer points to our next. So now the insertion pointer it's pointing towards this in second node. Insertion it's insertion. Okay. Now again we will check current pointer is not equal to current, which is false, which is true. So we move on. Now we check. Now we will increment the current value. So now incrementing current value. Current should be here. U double R E N T current. Now current is not equal to none. Yeah, it is true. We take the insertion to default head. Now moving insertion back to default head. Now here it is insertion. Now we will check whether 4 is here. It's else part, else part. Yeah. Now we will check whether insertion pointer is not equal to null. Yeah, it is true. Insertion data, it is greater than 1 is greater than 4. No. it give else we increment the current pointer. So we increment the pointer, insertion pointer basically, insertion pointer to 2. Now we will check who is greater than who. No, it is false. Now we will increment the pointer. Now it's pointing to this insertion pointer. Now we will check insertion pointer is equal to current. Yeah, it is true. It comes out with loop. Now we will increment the current vector. Now again incrementing current, CURRENT current. Now we will check again. Default, setting default head. Here it's set as default head. Default head, that is insertion pointer. Again to default head. Now we will check. While insertion pointer is not equal to current, yeah, it false. Then insertion data is greater than equal to current data. No. We increment. Again we increment the data. Now it says insertion data is greater than equal to current data. Now we swap the values. Swapping the values of 3, it is 4. Now insertion pointer uh, is currently here and the current pointer is here. We again follow the loop. Insertion data is not equal to current data. Yeah, it is true. Else insertion data should point the current pointer. Now it is again equal to current, which is true. It comes out to the loop. Now current pointer increment by 1. So in current pointer increment by 1, current pointer is pointing to the null value. This is our current pointer is equal to null. Then it's back out to the loop and we give a the linked list is sorted. LL is sorted 1 2 3 4. Previously it is 2 1 4 3. Before sorting, it is before sorting and it is after sorting. So what is the time complexity of this? Time complexity of this is basically is traversing the current value till n. So it's carry a big of an operation inside a loop. It's again running a loop till insertion pointer while not equal to current. Suppose our insertion pointer is here and our current pointer is here. The worst complexity should be big of 1. Now we put into big of 1. So it's become big of complexity, time complexity. What is the space complexity? Space complexity we are not using. We are using 3 pointers, which is as default. So the space complexity would be big of 1. Simple. Now we will do code part. That code. Firstly, we have to define 3 pointers. Is this node star default head, which is pointing towards the head. This node is our current pointer, which is also points the head. Node star. It is our insertion pointer. So it is also pointing the head current. So now we will traverse the linked list with the current. While current is not equal to true, at every traverse we set our insertion pointer to head, which is a default head. We are not using here 1. If we are using 1, it get a chance to basically we have to return the head of the. So if we change a, if we done any by mistake we have done any changes to it does not return to the head pointer. So for that we are making a default head pointer always points to the head. we will traverse the insertion pointer to check insertion not equal to current. Why not equal to current? Because we can't go beyond the current pointer. So it's while. Now inside while we have to check whether our insertion value, it should be value, yeah, it should be value is greater than current value. If it is greater, then we swap by making a temporary array, temporary variable, temporary is equal to current data, which holds the value of the current variable. Now we will set current value to temporary to insertion value. Then we will set our insertion value to current data. Basically it is equal to 10, so we are putting here. We can say we are performing swap operation. Now part of this, we increment our insertion value, sorry for that, insertion value, incrementing value by 1 x. Now we have to also move our current value. So now current is equal to current dot next, simple, and at the end we have to return head of the linked list. Okay. So let's check. Yeah, it's work. Here you can see it's working fine. And thank you.